Technology conference and technology doesn't work.
We're on.
So hello everybody. It's my great pleasure to introduce George Danezis. He's a researcher at the Catholic University of Leuven in Belgium, and his work focuses on anonymous communications, and his talk will be on traffic analysis. And welcome, George.
Thank you, Andreas. It's a great pleasure to actually be invited to speak at the CCC. A few years back, I did talk about some preliminary work I was doing as a young research student on the traffic analysis of HTTPS traffic. And then 2 years ago, I spoke about the mixed minion format, which was on anonymizing communications. So now I'd like to give you a slightly more high-level talk about this kind of new discipline that is emerging from some body of work that a lot of researchers have been working on in the last 5 years, which is the field of traffic analysis. I'm very excited about it, and I hope I can actually share some of this excitement with you. Now, this is a talk about traffic analysis. I'll talk about lots of cool, neat tricks without going too much into detail on any of them. I do actually know the details of most of them, so if you want, you can challenge me to go into them if you're particularly interested. I'd like to, of course, take a historic overview of traffic analysis and present first its military root. Like most of the security technologies we're using today and we're thinking in the open, traffic analysis has originated actually from the military, and the military has much more experience in it probably than we have, since we're only beginning. Then I would like to set traffic analysis issues on the internet and the public networks as we know them, and then discuss a bit about how to extract and use location data and extract from them high-level intelligence rather than just bits and bytes at the network level. Of course, no talk on security should avoid defenses, even though the field of defending against traffic analysis is quite young. And I'm going to then present a few policy issues at the end. Now, let's first define what we're going to be talking about. What we are interested in is a class of techniques that use traffic data in order to extract and information, or in order to generally violate security policies of secure systems. Okay? Now, this is opposed to interception of content of communications, or cryptanalysis, which is breaking basically the ciphers that encrypt the content of communications. And traffic analysis is a set of disciplines that use traffic data. Now, what are traffic data? They are the identities or call signs of communicating parties. Okay? Alice and Bob as names are traffic data. They are, of course, the time and duration and length of communications and transmissions. Then, of course, these days, with mobile devices everywhere, traffic data is often the location of the device, or in GSM networks, the towers you're talking to, or the towers you can see, and so forth. In Wi-Fi, it is the access point. And throughout this talk, please note that I'm not going to be talking about the use of content of communications, just this high-level information of who is talking with whom. Now, the controversial starting point for this talk is a quote that you can find in Susan Landau's and Whitfield Diffie's book, Privacy on the Line. They were discussing about what was known as the crypto wars, i.e. the attempt of the US government and other governments to restrict the use of cryptography in the 90s. And the quote in this book is quite challenging, because they say that it is traffic analysis and not cryptanalysis that is the backbones of signal intelligence. Okay? And we're going to see to what extent that is true, but it kind of highlights the importance of traffic analysis over what we conventionally look at when we think of security. And the question, of course, is that was the case when it came to signals intelligence, i.e. competing armies trying to get intelligence about each other. But then, how is that true for the internet today, and how we're going to be seeing this field being applicable to civilian communication systems? So let's start from the military world. My main source here is Herman. He wrote a very interesting book called Intelligence Power in Peace and War. And Herman was the chair of the Joint Intelligence Committee in the UK that is running one of the biggest spy operations in the world. And he said that about traffic analysis, that it allows basically people to find the target's locations, the order of battle of the units, and the movement of units. This is its tactical information. So it's already important for an army to use traffic analysis and analyze patterns of traffic to find targets, order of battle, and movement. But he also said that looking just at who is talking with whom on a battlefield allows you to discern the intentions and the state of minds of the enemy. Okay? And this is already quite high-level information. It's not just about which units are where, but whether they are ready to actually engage in operations, or whether they're just assuming a defensive role, whether they expect to be at war soon, or whether they expect to actually disband soon. Okay? And he really created, and he has a very nice picture in his book, which I didn't actually copy, of a pyramid, where he says the bulk of the information is actually from RF direction finding, okay, in signal intelligence. So you listen and try to find where are the points that are transmitting. Then you use traffic analysis. You look at who are these people and what are their call signs, how often they are transmitting, at what frequencies and all that stuff. And then only when you have performed traffic analysis and you have selected some targets of interest, you actually throw your clever mathematicians to do cryptanalysis and try to break the codes. If you try to break all the codes, probably you will not have enough mathematicians' time, and definitely you will not have enough translators, transcribers, and intelligence personnel to even read the communication. So traffic analysis is used in this context as target selection. And the second way of thinking it is again presented by Whitfield Diffie, in the context of information warfare, and this is maybe a bit of an esoteric slide, but it kind of really goes to the point of what are traffic analysis and traffic analysis prevention techniques, which is, he says, Whitfield Diffie says, what is basically information warfare? His first comment is, it's not just a bomb in the computer room of your adversary. And he points out that modern warfare has dramatically changed, and he presents as the example air operations. In the Second World War, there was a very particular cycle in engaging in a bombing raid, for example. You were sending your reconnaissance planes, they were taking pictures, you were selecting the targets when they were coming back and the pictures were developed. Then the bombers went away, they bombed away at night, they came back. Then you send the second wave of reconnaissance planes, they took more pictures, they came back, they got developed. You looked how the targets were destroyed or not, and then you recurse. Okay? And that creates a cycle of operations. This cycle takes 3 days or so. Okay? Now, he compares that picture from the Second World War operations to the Iraqi war, the first one in '91, where he said that basically the same planes, okay, were used in order to actually take photos, bomb, and do the assessment of the target destruction. They were automatically being dispatched as soon as the targets were not being destroyed. Okay? And all the information and the intelligence that they were gathering while still being in the air without landing was actually communicated back to do the assessment and get the new orders. So this cycle to basically do militarily the same thing, which is destroy a target, was in the order of magnitude of minutes. Okay? So on one side, in the Second World War, we have this operational cycle that takes 3 days, that has been reduced into an operational cycle that takes a few minutes at a time. Now, what has made this possible? Okay? And this was made possible because of course, the communication and the information technology we have today. Okay? And that is the advantage that high-tech armies have today. Now, at the same time as information technology allows the army to have much smaller cycles, it exposes them to greater dangers. And these are the dangers that basically people can listen into their communications, decrypt them, but most importantly, find their locations and do traffic analysis and try to avoid being destroyed. And really, trying to avoid being subject to traffic analysis is creating such an expense on the military system that is widening this circle. So from minutes, you're again forced to use less communications and go back to the realm of a few hours or a few days in order to perform your operations. And for a modern army, this is extremely dangerous. So let's look at some concrete attacks from the military world. Before even the existence of radio communications, people were already realizing that one could extract information that is not just textual. So they were planting wires next to, in the earth basically, and tapping the earth returns of the adversaries during the trench warfare. And every time there was a certain pattern of transmission, they were expecting basically the artillery to start shelling them. But of course, the heyday of traffic analysis techniques was when radio communication started becoming dominant, and in particular at sea. At sea, it's quite difficult to actually have cables, and even optical communication is difficult under bad weather conditions, so ships have to talk by radio, and other ships will be intercepting their radio communications and basically trying to get their intentions. In particular, operators that were sending Morse messages, even encrypted Morse messages, had a very particular what was called a hand. Different operators type Morse with a slightly different way, in the same way that my voice is different from your voice. And other operators were becoming very, very good at picking up this signature and telling which ship is where by the fact that their operators were the same. And ships were identified just by the operator's hand. Many more examples that I'm not going to go through. In particular, identification of radio equipment is also relevant to GSM phones today. But the question is, why is traffic analysis, rather than looking at content, so valuable? And in the military world, it's really valuable because it offers a lot of information. And it is actually cheaper to extract and automatically process than message content. Okay? For message content, you have to have someone translating it and understanding it, and then condensing it into an intelligence report, whereas to some extent traffic analysis is just automatically picking up a lot of signals, doing classification of them, and then passing them on to analysts. Now, each signal is of less value, but the aggregate actually gives you a lot of information. And of course, one cannot see traffic analysis versus cryptanalysis because they are complementary. Modern intelligence uses traffic analysis to select which targets to actually listen in more carefully to. Of course, and this is going to be maybe a recurrent theme in this presentation, there is also the issue of jamming communications and which communications jam, which is also associated with traffic analysis techniques. Now, without wanting to bore you with the military world, it's interesting to see how these guys tried to solve the traffic analysis problem and provide defenses in order to maybe get inspired about what we can do. And in the military world, there has been quite a few technologies to try to prevent basically leaking information by telling the adversary that there is a communication or telling the adversary who's talking with whom. And the kind of recurrent principle underlying these techniques is the fact that you try to make the adversary spend a lot of resources, which is time and energy. Energy in the terms of physical energy, not human capital, in order to detect and possibly jam the communications. So one key technique is frequency hopping. What you do when you transmit is you just use a pseudorandom number generator that is cryptographically strong and change your frequencies all the time. Someone who does not have the hopping sequence basically will have to listen into the whole spectrum, meaning that they will have to use a lot more power than you have to use in order to transmit. Okay? So there is an imbalance. Maybe you can win this way. A second technique is to use spread spectrum, which is slightly too complex to explain in huge detail here. But basically, instead of sending a high-power signal on single frequencies, even frequencies that hop, you just spread your signal over a very, very large chunk of the bandwidth, and using a secret spreading sequence that allows you to recover it. Someone who doesn't know that sequence will find it very hard to actually detect that signal under the noise floor, and will have to use extremely precise equipment to cancel the thermal noise in the circuitry and pick up your signal. And then there are other more esoteric technologies like burst communications. You most of the time not talk and then suddenly send a really high frequency signal with a lot of data and then stop talking again while you move probably. But the most important thing, and this is I think a recurrent theme in military security, is that all of this technology was really supported by clear security policies. For example, ships about to engage in some operation at sea were not to talk until basically they strike the enemy. And doctrine, of course, and training, and people knowing when to transmit and when not to transmit and what information is leaked. And maybe this is one of the key differences with the civilian kind of networks, that basically our users are not really trained or